Hi, welcome to the Society of Interventional Radiology Conference 2021. I am presenting a multimedia primer of the physical exam of the hemodialysis AV fistula and graft. Let's dive into it. So, a fistula is created when a vein gets ligated and its end is connected to an artery. The vein gets bigger. The vein is also superficialized closer to the skin for easy access for dialysis. A graft, in contrast, is a connection between an artery and a vein that is established with a synthetic material. Physical exam evaluation of an AV fistula graft involves three sections: the look or inspection section, the feel or palpation, and the listen section. Look. So first, before you, when inspecting an AV fistula, there are two questions you should ask yourself. Is this a new access or an established dialysis access? And secondly, where is the scar? That's the location of the scar will allow you to predict the type of access that you're dealing with. A forearm or radiocephalic fistula will have a scar on the radial side of the wrist. The upper arm fistulas include a brachiocephalic and a basilic vein fistula, and a brachiocephalic will have a horizontal scar at the elbow crease, while a basilic vein fistula will have a long scar, typically on the inner side of the upper arm. You can have complex scars. Typically, long scars are created when veins are transposed, like in this case, the cephalic vein in the forearm is transposed, looped, and anastomosed to the brachial artery at the elbow. Other things you can look for during an AV fistula inspection is the width of the fistula itself, the length, the side branches or collaterals that may exist. Aneurysms can be obvious, not this obvious all the time, but quite obvious. Aneurysms and pseudoaneurysms. Signs of infection, swelling, erythema, tenderness, purulence, a swollen arm as well can all be obvious. Moving on next to the feel or palpation section of the exam. Feeling the fistula or palpating the fistula is best done with the ball of your hands. This increases sensitivity for very faint thrills. A normal AV fistula would have a strong thrill that is felt both all through the cardiac cycle, and it's strongest at the anastomosis. A juxta-anastomotic stenosis will create a diminished thrill felt throughout the fistula. Um, a special maneuver called augmentation can be used to identify um, juxta-anastomotic stenosis as being the cause of AV fistula malfunction. When you occlude the outflow segment of the AV fistula, the thrill is diminished and is replaced with a pulsatile AV fistula. In an augmentation test, you're occluding the distal outflow segment, and if you have a juxta-anastomotic stenosis, then you don't increase the pulsatility, and there's practically no change, telling you that there's a problem with the inflow. Outflow stenosis is exactly what it means. It's just a blockage anywhere in the outflow of the fistula, and this creates a diminished or lost thrill, and is replaced with a hot water hammer pulse, a very strong pulsatile feeling. Fistulas can have collaterals. Collaterals diminish the functionality of fistulas and the ability to mature. To identify for if a fistula has collaterals, like we did before, we occluded the outflow segment of a fistula, and when you do this correctly, the thrill should be diminished and it should be replaced with a pulsatile fistula. When you have a collateral vessel instead, the thrill will persist and telling you that you have a collateral vessel, which is allowing the fistula to actually flow out, even though you have occluded the true outflow of the fistula. A maneuver called sequential occlusion allows you to identify the specific location of the venous collateral. This is done by sequentially occluding multiple segments throughout the fistula. When you do this, normally you will lose or you would diminish the thrill within the fistula and you replace it with a pulsatile fistula. But as soon as you cross the collateral, the thrill will be returned back to the fistula, letting you know that there's an outflow that is different from the outflow that you're occluding. Other special maneuvers include the arm elevation test. This is used to confirm patency of the outflow of the fistula. It's easily done in an aneurysmal or a very wide fistula because you can easily see the aneurysm or the fistula collapse. And this is done by, first of all, evaluating the fistula with the arm in the normal position. And you see the aneurysmal segment right there. If you lift the arm above the level of the heart, if the outflow is patent, the fistula and the aneurysm should collapse, telling you that there's no outflow issues. The third and final segment of the fistula exam is the auscultation, and this is done with a stethoscope, and a normal bruit is the normal sound that you're expecting to hear when you auscultate the fistula, and a stenosis will turn the normal bruit into a high-pitched bruit, telling you that there's an occlusion somewhere within the fistula. Thank you.